tutorial, episode 2. In this episode, we are going to learn how to draw basic geometry objects in SDL2. Let's go to the main function. In this main function, you can see that we have already encapsulated the SDL program in a GameEngine class. Without looking into the definition, let me explain what's going on here. In the first line, when we make a new GameEngine instance, it will initialize the SDL system in the constructor. Then we use the init function to initialize the required member for SDL. For example, we will create a window inside this function. If there is something wrong, then we print out the error message and then delete the game, return 1 to indicate that there's something wrong. Otherwise, we will go into the game loop. In the game loop, remember that we will handle events and then render the object on this window, and then we will need to update the game if necessary. After we exit the loop, then we need to clear all the variables in the created in the game init step before we leave the game. So let's go to the game engine and see what is in there. First of all, in the header file, we can see that the game engine has a constructor. As I said, in the constructor, we will initialize the SDL system, and we will have our init function. In this init function, it will initialize all the required members for the engine. In this base class, we have only a few things that we need to initialize. For example, we need to initialize the window because it is the place where we put our object. And we need another object called the SDL renderer. It is a structure representing rendering state. You can see here, summary. So it is this renderer that we use to render stuff on window. We will see later how to use it. So let's go to the code and see how we initialize the SDL system. As before, we will initialize everything in this tutorial for conveniency. And if there's something wrong, we will print the error inside the error message and then make the set false. And in the destructor, we will close or quit the SDL system. Now, the most important part in this game engine is the init part. It will initialize all the required SDL variables. For example, we create the windows as in the episode 1. And the difference is here that we create a renderer using the SDL create renderer. If you look at the summary on the right hand side, you can see that this function will create a 2D rendering context for a window. And you can look at the explanation of the parameters and see what's going on. So the first parameter is a window. That means we are going to create the renderer associated to the given window, and the index is the index of the rendering driver to initialize. We set it to -1, so we are going to initialize the first one actually. The flex here will indicate the properties of the renderer we want. Here I use the SDL renderer accelerated, meaning that we would like to request hardware acceleration. Now, that is the initialization code. Once we claim the window variable and also the renderer variable, we need to remember to reclaim the memory. So we do so by using SDL destroy renderer and also the SDL destroy window. Okay, let's go to the game loop. The game loop is quite simple. It has 3 components as before. The first one is to handle the event. And secondly, we need to render stuff on the window. And finally, we might need to update the game state. So that is our game loop. In the base class, we only handle one event, the SDL code event. It will close the window of our it will close the window and set Q to be true, so it will let the game load exit. Okay, now let's see what is episode 1, and you can look at the code for episode 1. Now, since we have the base class games engine, then actually the episode 1 is totally a copy of the game engine. When we run it, we will see what we have last time. We see a black window without anything because we have never drew anything on it. And it only responds to the close event. And it also it also responds to the command Q, the hotkey on Mac. Now, let's move to the second part. First of all, let me show you the result of this episode. In episode 2, we are going to create a game engine, and we are going to initialize it, the window with title tutorial, the width 800, and I set the height to be 200. And we're going to the game loop. We override the render part. Let's see the result. So here is what we are going to do today. We're going to draw some rectangle, some point. You can see that in the dust cell here, there are some point. They are tiny and hard to spot. So I draw some lines connecting these points in the last cell. So let's go into the code and see how I do it. First of all, in the definition of the episode 2, we are going to override the render function to add more functionality. And in the render function, we are going to call the draw function to draw whatever on the screen. So let's go to the implementation. For the render part, we are going to set the render color to be white. If you go back to our application and see the background color, you can see that it is white. It is because of this code. We set the draw color to be white. So in this function, when you read the documentation, you can see that the first argument is the renderer we would like to set the color to. And the following 3 or 4 arguments are RGBA. That will tell us what kind of color you are going to use. And the A channel, the alpha channel, tell us the transparency of the color. And we are going to set the viewport to be null, meaning that we are going to control the whole window or use the whole window as our canvas. And then we are going to clear the renderer. That will make the background to be white. And then we call the draw function to draw things on the canvas or the window. After we are done, we are going to present the renderer, meaning that we are going to put everything on the renderer to the window. So if you comment out this draw function, we will get only the blank window with white background. So that's what we get. It is this draw function that adds things to the window. Let's go to the draw function. In the draw function, the first thing we do is to draw some vertical green line. If we go back to our function, and you can see that there's 3 vertical green lines. 1, 2, 3. Separate the window into 1, 2, 3, 4 parts or 4 cells. Now, to draw lines, we are going to do the following. First of all, we are setting the color to be green. We need to do so because originally we have set the color to be white. In order to use the green color, we need to set it to be have the 255 on the green component and 0 on the other 2. Then we are going to draw lines using the SDL render draw line. The first argument is still the renderer that we would like to draw the line, and then the first pair of numbers x1, y1 tell us where we would like to put the first point, and the last pair of numbers tell us the endpoint of the line we would like to draw. So before we move on, let me tell you the coordinate system in SDL. Within SDL, the origin is actually here at the upper left corner. So this is 0, 0. And the x coordinate is the same as we learned in calculus. It is the horizontal line. That is the x-axis. And also the vertical line represents the y-axis, but with only one difference. Now the y-axis go down as the positive direction, meaning that here the point the 0, 0 here, but the point here is not with negative y coordinate, but with positive y coordinate. So that's the only difference. So if you look at the code here, we draw the line from W 0. So the y coordinate is 0 and the x coordinate is W. So the first line with the first point here. And the second point is in the same width, but with different height. So we have W height represent the point here. So SDL render draw line will draw a line between this one and this one. So that's how we get this green line. And subsequently, we draw the second and the third line here using the same command, but changing W. And next, we would like to draw a red rectangle in the first cell. We do so using the command called render draw rectangle. In this function, we take two arguments. The first argument is the renderer we would like to draw the rectangle, and the second argument is the SDL rect tell us where we should put the rectangle. The SDL rect has 4 components here. The first 2 components, 50-50, represent the upper left corner, and the third component means the width of the rectangle, and the last one is the height. So this one represents x, y, width, and height, the 4 tuple. If you look at the function, look at the window, that will tell us that when we call the render draw rect, we will have a rectangle appear here, where this upper left point has coordinate 50-50, and the width here is 100, and the height is also 100. So you can see that the color is red because I changed the color one line above to red. Okay, that's how we do it. It's quite simple. You can see that only the logic to draw things are quite similar to each other. First of all, you set the color you would like to use. For example, in here we draw it, we make it to be red, and in the next example we make it to be blue. And then we choose our function to draw. Here, in the first cell, we use the render draw rect, which means we are going to draw the rectangle without filling inside. And the second one is the similar one called SDL render fill rect, meaning that we are going to draw a filled rectangle like this. Now, we have to put our argument or the rectangle in the absolute coordinate, meaning that we need to draw everything with respect to the 0, 0 here. For example, when you try to draw this rectangle here, we need to mix the xy coordinate to 250 and 50. So that this point has coordinate 250 and 250 here and 50 here as the coordinate. The width and the height does not change. So that's how we do the drawing in typically. But the problem is, sometimes we would like to have a relative coordinate. For example, I would like in this cell, I would like to focus on this cell only and have this point relative to the 0, 0 here. So we can do so using a set viewport function. That basically means that we would like to focus on a certain rectangle. In this case, in the third cell, we would like to say, we would like to focus on the rectangle here. This rectangle actually represents the area in the third cell. And when we set the viewport to it, then everything we draw is actually relative to the 0, 0 here. So that's the reason why now the system where the points has 150-50 representing this first point here. So we don't have to do the math ourselves when we restrict ourselves to this point. We just need to put the relative coordinate to this point here. The same thing is for the last part. We need to change the viewpoint to the last cell and then draw the lines connecting all these 4 points here using the SDL render draw lines. You can see that here in the third cell, we can hardly see the points. And also in the last cell, the line is quite thin. And in SDL, we don't have a way to control it and make it bigger. To make it bigger, we are going to introduce a third-party extension called SDL2 GFX. That's the content of next episode. Hope to see you soon.